Greetings, I'm Anthony Sabah, and today's session is on string object interning in Python. Um, Before getting into string object interning, let me say what is object interning. So object interning is a practice of sharing references, and due to this, C Python saves significant memory. And when we speak about string object, it's a collection of uh, characters, sequences of Unicode characters, and there are three different types of encodings. The first one is Latin 1, which require 1 byte of memory to store characters, and the second one is UCS2, which require 2 bytes of memory to store characters, and the third one is UCS4, which require 4 bytes of memory to store characters. And the languages which falls under Latin 1 category are English, Italian, Swedish, and Norwegian. And the other non-Latin characters are from languages like Chinese, Hebrew, and Japanese, etc. This is because these non-Latin languages require more than 1 byte to store its characters. That is why we have this UCS2 and UCS4 kind of encoding standards. And though we say it's a sequences of Unicode characters, each individual characters present in a string object has its own identity. And moreover, whenever Python gets initialized, it loads the Latin 1 character set as shared objects into the memory. That's why the interning is more flexible in Python. Okay? So let's have a demonstration on that. So let me create a string object, say x equal to SEBA, SEBA. And we know in order to get the address of this x, the ID function is used. So the address of x is displayed now, and of course the type of x returns string. Now let us check whether the individual characters of this string has its own address or not. So let me iterate for I in range of, say, len of x. Okay. And let me print the address of individual characters. Address of x of I, comma, ID of x of I. This ID of x of I returns the address of individual characters. Yes, now let us check. So the address of S is this, address of E is this, address of B is this, and address of A is this. Now let me create another string, say y equal to Harriet, and see ID of x. So now the ID of x is different. Sorry, this is not ID of x. It should be ID of y. ID of y. So ID of y is different from x because both the string sequences are different. And now let us try to print the address of each character present in the string y. So for I in range of len of y, and print x of I, comma, ID of, sorry, this is not x, it's y. Yes. So Harriet, all the characters has its own address. Now, when we compare the addresses, the address of E is same. and the address of A is also the same. This is because the characters E and the characters A are interned. Okay? And the next one is what type of strings are interned? Not all the strings are interned in Python programming language. So any strings whose grammar is a string identifier, that strings are interned. Clear? So strings that satisfies the identifier naming convention. Okay. So only such strings are interned. And also the strings which are to be interned should be a compile time constant. So any strings which are created at runtime or any strings which are returned by methods or functions, those are not interned. And also the maximum length of strings that can be interned are 4096. Earlier in Python 3.6, if the length is greater than, length less than or equal to 20, those strings get interned. But in Python version 3.7, the length has been increased to 4096. And there is one other peculiar case, that is, if the string is a product of constant folding and if its length exceeds 20 characters, then such strings are not interned. This is because this kind of patterns are not likely to be an identifier. That's why a constant folding with more than 20 character strings are not interned. So let me demonstrate that. X equal to Seba concatenated with feature. So now here constant folding happens, right? Because we have two strings, two constants, and the two constants present in the expressions of Seba and Peter, and these two constants in the expressions are folded, and it becomes a single string, right? And let me create another string. Now let us see, X is Y. Yes, it returns true, which means we have to constant folded product of constant folding is also interned, provided it should not exceed more than 20 characters. Right. Now let us check the equivalence of both the strings. To check equivalence, the equal to operator is used, X equal to Y. So that's also true. And at this point, I'd like to mention one thing. Whenever an object creation statement gets executed, whenever a string object creation statement gets executed, Python checks whether it is whether the same string exists in the memory or not. In that case, it cannot compare the characters present in the string one by one because it will be a time-consuming process. Therefore, whatever string is composed, that composed string will get a hash value. Let us check that. See, hash of x. Hash of x, you're getting a number, and then hash of y is also the same. And then let me try to get hash of the string constant. Okay, so this Seba feature will get a hash value, and that hash value is the hash for x as well as y. So whenever a string object creation statement gets executed, Python checks whether the same string already exists through the hash value. So even if it checks by comparing the values, it takes more amount of time. So in order to speed up the lookup process, this hash values are taken into account by Python. Okay. And now let us check by giving another pattern of strings. Say, so this pattern does not follow the identifier naming conventions, right? So let us check whether this gets interned or not. So X is Y, definitely this returns false because they do not follow the grammar of a string identifier, right? And how about special characters? When we say about identifier, the characters which can be present are ASCII letters, digits, and underscore. Even white spaces are not allowed. So let me again use a string constant starting with an underscore. Hyphen, underscore. And obviously this X is Y returns true and X equal to Y also returns true. Right. So now let us check this constant folding plus greater than 20 characters. Right? Say X equal to A, B, C, D, E, F, G, H, I, J, K, L plus the same A, B, C, D, E, F, G, H, I, J, K, L, M, N, O plus P, Q, R, S, T, U, V, W, X, Y, Z, A, B, C. I guess this is more than 20 characters now. And now Y equals A, B, C, D, E, F, G, H, I, J, K, L. And then A, B, C, D, E, F, G, H, I, J, K, L, M, N, O. And now P, Q, R, S, T, U, V, W, X, Y, Z, A, B, C. Okay. So it is constant folded. At the same time, its length is greater than 20. So obviously, X is Y returns false. But X equal to Y returns true because their hash values are same. Right? Okay. And apart from this, there is one exception. Empty strings are interned. So this is an empty string equal to. So now X is Y returns true and X equal to Y also returns true. Okay. But if we look into certain applications like natural language processing, where we have a bag of words and certain string patterns may repeat several times, which may not follow the identifier grammar. And in that case, when we are taking the frequency of such non-identifier patterns, definitely it will be a time consuming. So in that case, one can forcibly intern a string. So there is a method intern which is available in the sys module. So this intern method can be used to forcibly intern strings. Say import sys x equal to sys dot intern of and y equal to This dot intern of now let us check x is what returns true because we are possibly intern the string which does not follow the identifier grammar. Okay. And when we look into the string methods, let us use the function dir. So dir of x. So this dir returns what are all the functions associated with the object, string object x. And here you can find two sets, something like dash dash add dash dash. But this is not a single line, it is underscore. Okay. So it's like underscore and then underscore and then the method add and again it is underscore underscore. So since we have double underscore prefixed and suffixed, we call all these methods as dunder methods. D-U-N-D-E-R, dunder methods. And of course, these are magical methods, and many of these dunder methods are implicitly invoked. For example, we have certain dunder methods like dunder multiply, dunder not equal, etc., etc. So already such methods are mapped with the respective operators. So if it is not equal and when we use the not equal to operator, immediately while the statement gets executed, the dunder NE gets executed. Okay? And moreover, all these dunder methods are used to enrich the Python classes. And below that, you can find another set of methods without these dunders. So these methods are the public methods, and you can invoke them with the help of the string object. X dot find, let us check whether S is available, whether E is available. So E is available at the index 8. So plenty of methods are available. You can explore all them, and split and join. These methods will be very useful for almost in all the applications. These two methods plays a major role. Say for example, if I type A equal to good luck, and I say A equal to A dot split, which means the string A is splitted with respect to spaces, and always this split is converted to a list of string. So empty separator. A equal to A dot split of, I have to leave a space there. Yeah. Now I print A, I get a list of strings. Right. And now if I want to join the strings which are available in the list, now let us check what is the type of A. Earlier it was string, and now it becomes a list. Okay. So A equals, let us use an underscore dot join of A. Now print A, it becomes a string. Join becomes a string. That's all about string object interning, and thanks for listening. Thank you.